Welcome back to phase 3 of the Efficient Frontier project in Excel. So far we've pulled the data from Yahoo Finance. We've calculated the returns for 4 different stocks over the last 5 years. We then use those returns to calculate the average return, average or daily standard deviation, annualize those two figures, calculated the correlation of the 4 stocks, and covariance of the 4 stocks. So that brings us to the Portfolio Statistics tab, where we're actually going to calculate the return and standard deviation of the portfolio. All right, so ultimately what we're going to do in this Efficient Frontier is determine how much to invest in each of these 4 securities for a certain target return. For the time being, what I'm going to do is go ahead and start out assuming that we equally weight them. All right, these 4 cells up here are manual entry. Everything else in the spreadsheet, except for the input prices here, really should be automated. Okay, so that's why I want to actually use equals and reference these cells rather than just put them in as hard numbers. This is where most students start to mess up. Right around here, they'll go ahead and manually type in these weights. I only want you to manually type them in here. All right, make sure that they're referenced here. This one is referencing the Amazon weight. This one's referencing the Walmart weight, for example. And then down here, I want a sum of all those weights. Okay, this cell should always equal 1 or 100%, and that just means that we have 100% of our money invested in this portfolio. Okay, now when we do the weights down here, I want these to be carried forward from the top cells. Okay, so I'm just going to reference cell J2, go ahead and drag that over. Same thing here, I'll reference cell 2 and drag that over. All right, so that's the little bit of house cleaning. Now I actually want to get into why we're doing this. Okay, so we need to calculate these 3 cells here: return, standard deviation, and variance of the entire portfolio. All right, I'll start you off with the easy one. The standard deviation is just going to equal the square root of the variance. Okay, now we still need to calculate the variance and the return. Okay, so our return, if you'll remember from the class, if we have 2 random variables with 2 constants, all right, so this is much like having a weight and a stock times the return of a stock plus the weight of another stock times the return of that stock. All right, the expected value, or the expected return on that, is going to be the weight times the expected return on the stock plus the weight times the expected return on the other stock. All right, when we have 4 stocks, this just grows linearly. Okay, so we're going to have 4 different weights and 4 expected returns. Okay, we've already calculated those expected returns over here. We have our annual returns over the last 5 years. We're going to go ahead and assume that those are our expected returns. Now, if you were using this in an investment setting, maybe you want to go ahead and adjust these. Maybe you think that Chesapeake is going to return a little more in the next 5 years than it did in the last 5 years. Okay, that's perfectly fine. For right now, we're just going to stick with what the historical data tells us. Okay, so to calculate our return, I'm going to use the weighted returns box here. Okay, so first off, I'm just going to reference the returns that I calculated earlier. So Amazon's return is going to equal 34.30% in cell C3. Okay, I'm going to go ahead and drag that over. Now, I'm only investing 25% of my money in Amazon, so I need to go ahead and multiply that return by 25%. Okay, and I can drag that over as well. All right, now my total return on the portfolio is going to equal the sum of all of these. Okay, so that's equaling how much I invested in Amazon times the return of Amazon. That's equaling how much I invested in Chase times the return of Chase, how much I invested in Walmart times the return of Walmart, and same for Chesapeake. All right, so this will give me, if I invest 25% in each of these stocks, this will give me an expected return of 15.15% per year. All right, and that should look something like this formula, where we have how much we're investing in Chesapeake times the expected return of Chesapeake, same for Amazon, same for Chase, same for Walmart. Okay, so now we need to calculate the variance. There's 2 ways to do this. All right, there's the easy way, which I'll go over later, but for right now I want to go over the more intuitive way. Okay, so we're basically going to calculate variance the same way that we've calculated variance for a 2-asset portfolio. Right here I have the variance of a portfolio where we're investing some of our money in bonds and some of our money in stocks. Okay, so this is the weight that we invest in bonds times the standard deviation of bonds squared. Okay, the weight that we're investing in stocks times the standard deviation of stocks squared, plus 2 times the weight of bonds times the standard deviation of bonds, times the weight of stocks times the standard deviation of stocks, and the correlation of bonds and stocks. All right. Now, if we're thinking that this bond, this subscript B, is just another stock, okay, then this is now changed to a 2-stock portfolio. Right? Now, if we add a third stock, what are we going to get? We're going to get another variance term here, where we have the weight of stock C times the standard deviation of stock C squared. Okay, so I'm calling that a variance term. If we distribute the squared, we basically get the weight squared times the standard deviation squared, or the weight squared times the variance. All right, so we'll get that for the third stock, but rather than just one more covariance term, we're actually going to get 2, because stock C is going to covary with stock B, and it's also going to covary with stock S. When we add in a fourth stock, we're going to have one more variance term, but then we're going to get an additional 3 covariance terms plus the 2 that we got with the third stock. All right, so we're going to get we're going to get 6 covariance terms and 4 variance terms. Okay, so I'm going to go ahead and use this equation in the spreadsheet. I'll show you a shortcut after we're done with this. For right now, I just want to stick with this equation. Okay, so I'm going to do very similar to what I did for returns. I just want to get the variance brought over. I have the variance calculated over here, and this is the annual variance from the annual standard deviation. All right, so I could either do the annual standard deviation squared or times itself, right? And I'm going to get 0.095, all right? Or I can just reference this cell directly, and it's the same thing. Okay, I'll drag that over. And now for my weighted variance terms. When we did weighted returns, we just multiplied the weight times the return, all right? When I'm doing the weighted variance terms, however, I'm going to want to square that weight, because we have the weight squared times the standard deviation squared, or the weight squared times the variance. Okay, so I'm going to have that equal the weight squared, okay, times the variance. You'll notice instead of actually using the caret 2 for squared, I'm multiplying it by itself. That's not really that important for a project this small. As your projects get bigger and bigger in Excel, this is actually faster for the computer to calculate. Okay, so now I have my weighted variance terms. So if I look at this equation, I have this portion, this half of the variance equation handled. Now I just need the covariance equations, which is going to be 2 times the weight of A times the weight of B times the standard deviation of A times the standard deviation of B times the correlation of A and B. All right, the standard deviations and the correlation are going to be lumped into a covariance term. All right, we've already calculated the covariance, so all we need to do is multiply that covariance by 2 and by the weights. All right, so let's go over here. We don't need to do this for Amazon and Amazon. We don't need to do this for JP Morgan in itself. We don't need to do this for Walmart in itself or Chesapeake in itself. All right, and since we are only we're doing the 2, right? We have the 2 in the equation. We really only need to do either the upper diagonal, the upper half of the matrix, or the lower half of the matrix. So I'm just going to do the upper half of the matrix here. The equation is 2 times the weight that I've invested in Chase times the weight that I've invested in Amazon times the covariance of Chase and Amazon. Okay, similar to how we did it in phase 2, I'm going to want to lock the row number on the blue cell here, so when I drag this, it's not affecting that that row number, and I'm going to want to lock the column letter of this red cell, so when I drag it to the right, it's not moving that column. So I'm going to lock the H here. And I will keep the purple cell, the covariance term, free floating. Okay, we'll drag this over, drag this down, and one more time. Now we have the upper half of the covariance matrix, right? Like I said, we don't need the diagonals because those are handled here, all right? The variance terms. And we don't need the lower half because we've put the 2 in there. Okay, so now what is the variance of the entire portfolio? Well, it's just going to be our variance terms plus our covariance terms. Okay, so I can just do a sum of the variance terms, do a comma for another array, and also add in these terms. Okay, so now I have my variance and my standard deviation of the portfolio. Right, so if we invest 25% in each of these 4 stocks, assuming the stocks perform how they did over the last 5 years, we're going to have an expected return of 15% per year with a standard deviation of 22 or 23% per year. All right, and if we played with this weighting, right, we could invest 20% in Amazon and 30% in Chase. That's also going to affect our returns and standard deviations. Right, I'm going to go back to the equal weighting, and I will see you in phase 4, where we will actually go over our solution and we'll figure out the standard deviation for all of these target returns, as well as how much to actually invest in these 4, and we'll draw our final efficient frontier. All right, so that's all for phase 3. I'll see you in phase 4.